Hello everyone, and welcome to our first event in our Core Insights webinar series. You'll have an option to hear this presentation in English or in French. You'll find the globe symbol at the bottom of the screen where you can choose your option whether to hear the original in English or in French. Before we get started, just some brief housekeeping points. Excuse me. We're going to be recording the session today. If you could kindly keep your microphone on mute unless you are asking a question towards the end. If you experience any tech issues or unable to see the slides or any other issues, please let us know in the chat and we will try to put that right. If you have questions during the presentation, you can put them into the Q&A function and we will try to answer them as we go along. Otherwise, there'll be plenty of time for questions at the end. We have 3 speakers today, and now I'm going to hand over to the first of those speakers, who is Jakub Vrba, who is our Senior Research Lead at Efficiency for Access. Jakub, over to you.
Thanks, Anita, and hi, everyone. Welcome to the first webinar of the Cool Insight series, which will focus on design and operations of walk-in cold rooms. As Anita mentioned, I'm Jakub Vrba, and I will moderate today's session. Next slide, please. Today's webinar will focus on scene setting and introduction to the guide that we published in collaboration with the International Institute of Refrigeration. Our IR colleagues will host the next webinar, which will be in June, and it will be a deep dive into the technical design of walk-in cold rooms. And then there will be a third webinar hosted by Wageningen University and Research, which will focus on operations and lessons learned from the field based on their research they have done in the Global South. Next slide. We've got a very packed agenda for today's webinar. I will introduce the key delivery partners and speakers in a minute and then set the scene for today's session. Arpana will discuss the importance of the value chain-driven approach, and Sonja will talk about system sizing and site review to enable efficient and effective cold room deployment. I will then touch on the most suitable business models and financing option before we open up to questions from the audience. But as Anita mentioned, you can also put your questions in the chat or the Q&A function during our presentations, and we will pick it up as we go. We should definitely have sufficient time at the end of the webinar to have a more interactive discussion with you all. Next slide. Let me briefly introduce you the key delivery partners of the guide. Efficiency for Access is a global coalition aiming to double the efficiency and halve the costs of off-grid solar appliances. And Efficiency for Access is jointly delivered by Energy Saving Trust, who I work for, and CLASP. Now, the Low Energy Inclusive Appliances Program, we call it LEA for short, is a research and innovation program delivered under the umbrella of Efficiency for Access. And then last but definitely not least, we have delivered this guide in collaboration with the International Institute of Refrigeration, which is an intergovernmental organization based in Paris with a key focus on promoting knowledge of refrigeration technologies globally. Next slide. In terms of our speakers today, I lead the Energy Access Research Portfolio at Energy Saving Trust and co-lead the research workstream under the LEA program. I have an engineering background and have worked in the renewable energy sector for about 8 years, including academia and the public and private sector. We have got Arpana here, who leads Enviu's venture building activities in East Africa. She co-founded Sokofresh and Shambani Pro, which are 2 agri-tech companies improving smallholder farmer access to climate-smart technologies. Sonja is a highly dedicated expert working as a consultant specialized in sustainable cold chain solution for agricultural value chains, in particular focus on tropical regions, advancing innovative environmentally friendly technologies. Sonja has several years of field experience, having installed multiple cold rooms in different African countries and over various value chains through different projects. And amongst those is also the walk-in cold room that won the Global Leap Award in 2022. With numerous trainings and outreach events to diverse audiences, Sonja contributes towards more awareness and knowledge creation. Next slide. Now let's turn the focus on the actual guide itself. The aim of the guide is to provide accessible and practical guidance for practitioners to specify, design, install, and operate walk-in cold rooms. We focus the guide on small walk-in cold rooms, kind of usually up to the size of a shipping container, 40-foot shipping container, and with the design focusing on pre-cooling and storing fresh horticultural and agricultural produce. So we are not talking about large cold rooms or sub-zero cooling for meat or fish. This is more focused on horticulture produce and relatively small scale. And the focus is on off-grid areas or areas that don't have reliable grids. And Sonja will talk more about kind of how we classify these later on. And again, the focus is on the global south, on hot climates, in particular Sub-Saharan Africa and South Asia. As part of this research, we produced two key resources. There is the full guide, which has a very detailed step-by-step guidance for practitioners how to design, install, and operate these cold rooms. And then there's a much shorter overview document, which is more of a summary for decision makers who might not have time to read the full report. The development of the guide was a 2-year effort, which was spearheaded by Giovanni Cortella and Jeremy Tate. There were 7 co-authors working with Giovanni and Jeremy, and over 40 direct contributors who helped to shape the report, in particular experts from Africa and India. So it was a truly collaborative effort with inputs from practitioners in these regions. We launched the report in December 2023 at COP28 in Dubai. And since then, it actually became one of the most downloaded reports on our Efficiency for Access website. So it is clearly an important piece of research that enables practitioners to effectively and efficiently install, operate cold rooms. Next slide. Now let's dive into the actual content. As you probably all know, the benefits of solar-powered walk-in cold rooms is mostly related to reducing post-harvest losses and contribute towards income generation at the farm or aggregator level. But it's also important to understand their limitation, which are succinctly summarized on this slide. So starting with the most important aspects, walk-in cold rooms are not a silver bullet, and we reinforce this point throughout the actual guide. They are a relatively expensive piece of kit, so their viability needs to be carefully considered before deciding to use them in the field. For example, there might be some instances where building a greenhouse supplied by solar powered irrigation would extend the harvest season, and it can be actually more economically viable than deploying a cold room to increase the shelf life. So it's always fine balance to decide when cold rooms are actually the right solution. So it's important to consider cold rooms in a holistic view rather than jumping to the conclusion that they are always the answer to the problem. So our very first step in the guide starts with the question if walk-in cold rooms are the right solution, and this should always be considered. Now, having a detailed understanding of the targeted value chain is extremely important before we design the cold room, because different value chains have different needs when it comes to temperature, humidity, length of storage, its seasonality, and other aspects. And we'll shortly hear from Arpana how they use the value chain-driven approach at Enviu and their other ventures. Designing, installing, and operating cold rooms is very complex, and I cannot emphasize this enough. So it is a completely different ballgame to other solar power technologies. For example, when we look at solar home systems, fans, or even refrigerators. So again, it's important to understand its complexity and walk it step by step. So we will try to unpack this complexity throughout the webinar series, but we still encourage everyone to read the full guide to understand the detail if you have time and you're interested in this topic. And today, Sonja will talk about the key design and site review considerations, and then our IR colleagues will do a deep dive in the next webinar. Now, although we try to keep the guide as concise as possible, it is more than 200 pages long, which demonstrates the complexity of deploying cold rooms effectively. Can we go back slide, please? It is very important to remember that solar-powered walking cold rooms are only one part of the cold chain, and are usually located at first mile to preserve food. So there are subsequent links in the cold chain between the cold room and the end user, and these really have to work to ensure that the food is stored safely, the quality is kept high, and the nutrition and value of the preserved food remains high as well. And then last but definitely least, the business models can make or break the cold room viability. So we really need to look carefully at what business models will be used and which ones are the most suitable for different contexts. And I will talk about these business models in a second, which is very important. So the cold room actually don't result in white elephants, as our colleagues at Wageningen like to call it. And I will talk about these business models and financing options at the end of the webinar. Next slide. Now, as I already mentioned, designing, installing, and operating walking cold rooms is complex. So we try to summarize the key steps in these 12 main steps, which are actually presented in the overview document, and we'll also refer to these steps throughout today's presentation. We will today focus mostly on the first 9 steps all the way to the go, no-go decision stage. And I should emphasize that this diagram is just a simplified version because there are many sub-steps that also need to be considered, and these sub-steps are explained in detail in the actual guide. Now that's everything from me for now. I will hand over to Arpana to talk about the importance of the value chain-driven approach. Over to you, Arpana.
Thank you. Hello, everyone. I'm Arpana, and I work with a company called Enviu. And what I want to do today is give you a brief introduction to Enviu and the approach we use, which is a systemic lens, value chain-driven approach to building scalable, sustainable business models. First slide. Next slide. We can move forward. Yeah. So just introducing the work that we do. Enviu is a global venture building studio. We have built 22 ventures to date, all in the nexus of solutions that impact people and planet. And a lot of our solutions are also use climate smart technology. So this is a selection of the companies. I think the one that we are talking about a lot is the hydrogen water taxi. So we developed and are building the first hydrogen water taxi in the world, which is quite exciting. We can move to the next slide. This is the areas we work in. Each area focuses on a domain. I won't spend too much time on it, but I'm in this East Africa region and working from Nairobi. Next slide. I want to kind of take a moment to talk about why our approach was chosen. So Enviu envisions a future that sees systemic change, not just at a micro level, but at a larger level. So if you look at the circle on the left, you'll see we see some sort of a gap in an industry or a system. It could be the food system, could be the textile system, it could be plastics, it could be mobility. And what we do is we do an intensive analysis, and I'll give you an example of what we did in Kenya. And we come up with innovative business models that could really impact that system failure and convert it into something really powerful. Our business models then become impact-driven companies because then they become investable, scalable, and grow on their own, and they become entirely self-sufficient. And these companies then partner with key players in the industry to kind of create that market change, which then results in a lot of systemic results. So all our big impact goals really happen at that stage where we're working with partners. And this is really a theory of change. I'll provide an example of how we have been able to see this in reality in Nairobi, or in Kenya, really. Next slide. So the example I want to take demonstrate our approach, but also it ties in very nicely with our topic, is our post-harvest loss program. So we initially set out to unpacking the food system in Kenya and where it could see an intervention, and we looked at post-harvest loss as a potential low-hanging fruit that we could intervene in. And we developed a 60-page report. I'll share some snippets from that in a while. But the key results of that, or the approach to that, was the value chain approach that we've been talking about, and really understanding who are we solving the problem for, how big is the problem, and what are gaps in the industry and in terms of solutions that we could really build out. Next slide. So I'm diving into that post-harvest loss program and the kind of solutions that came out of it. So if you see the graph on the top, this is one of the results of our study. We looked at post-harvest loss and said, where is most of the post-harvest loss happening? A lot of post-harvest loss happens at farm gate, as you can see, 37%, or 39%, depending on 39%, sorry. And so we built solutions along that chain. So we built 4 solutions. The one we're going to focus on today is the one highlighted in gray, which is our walk-in cold storage solution, our cold room solution. And the other 2 are also companies that are now in that stage of, well, Timba is scaling and Shambani Pro is getting ready to grow. So just to give you some context, to solve post-harvest loss, we saw that we needed cold chain at farm gate. We needed that cold chain to carry through all the way from farm to market. And that's where Timba, the company on the right, comes in. They take care of that entire supply chain. And then Shambani Pro sort of comes in at the farm gate as well, where it says all qualities of produce that cannot be sold to markets or for human consumption, the Shambani Pro convert it into value-added products. So it's not going to waste. Those are not so relevant for our conversation today, so focus on the cold chain of the solution. Next slide. Thank you. Whoa, it's a bit stretched, but I think just going back to our model, to give you an example of the companies we built. So Shambani Pro is a new business model. Soko Fresh is the cold chain company that we will talk about today. Timba is another company. Both those companies have really brought partners along or joined a movement to reduce post-harvest loss. And we've taken some of these big names in the industry and provided our services to them. And the idea towards the right, if you see, is together we're able to increase farmers' income, able to eliminate post-harvest loss, which was our goal, and in the process create jobs, create capacity building, etc. So this is just tying back our theory of change to what we do. We'll go to the next slide. So I want to kind of go into the post-harvest loss work and the process of building our companies. So before we even come up with these new business models, we look at the ecosystem. We look at the entire supply chain. So we look at everything from production all the way to markets, and we nail down where the problem is. So if you will see, sorry, I put too much information here. We're not going to go into the information, but if you would like the deck, happy to share that. We looked at where does post-harvest loss happen. We looked at what are the crops that are produced in bulk, where do the highest food losses happen, where does the supply chain kind of break down. And one of the key findings was it's mostly informal. Farmers are informal, traders are informal. And so we needed to kind of formalize the system in a way. And then the value chain. So how many middlemen are there between the farmer and the market? And where can we see efficiencies where we could really both return value back to the farmer, but also create some supply chain benefits for post-harvest loss. We also looked at smallholder farmers, what lives like, what is their income sources like, how many of them are there, etc. And we looked at some graphs that really helped us figure out and understand the problem. And so we'll go to the next slide. One of the problems that we came up with, actually, it wasn't our first solution. Our first solution was a market concept, but when we went on the ground and did some experiments, we realized that one of the interventions needed was providing cold storage or cold chain access directly to smallholder farmers. They didn't have it at the time. Nobody was providing it, or people who were providing it were not providing something that was affordable to farmers. So we said, let's set up a cold storage company that provides this as a service. So that means farmers can come in with their basket of goods and pay a small rental fee to store their produce there. We tested it, didn't work as such, but what we realized over time is we could actually, we needed to understand our customers better. They didn't have any money that they could pay, so we needed to develop or enhance the solution targeted to our customers. So we incorporated a market linkage concept. So the farmers didn't have to pay out of pocket for cold storage. They literally had, I mean, we could even pick up the produce at the farm, which is what we do now. They don't pay for anything, but we ensure that our produce goes through the cold storage and directly to markets very quickly. So on the left is a picture of the cold storage we use. It is a 5-ton container with solar panels on top. We have about 22 cold storages around Kenya at the moment. And if you see the little icon on the right, you'll see the regions we're in. All of our cold storages are off-grid, they are walk-in, and they are portable, so they can move with seasons. On the right, I want to quickly show you some of the experiments and learnings we had from a business model perspective. Again, I'm a business model expert. I know nothing about the technicalities of cold storage, so please save those questions for someone else. So from a business model perspective, one of the first things we look at is what is the need for cold storage? What we realized is the farther they are from urban cities, the more impactful they are, because those are people who actually need to aggregate and take them to market. What is the size of a cold storage? So we looked at small cold storages, those carry cold storages. We looked at big ones. We looked at utilization rate. What does seasonality look like on utilization? How can we create a price that is affordable to the farmer? How can we create a model that is commercially viable? And so we ended up with a model where we said a kg of produce can be stored at 2 cents per kg. And that helps us to be a commercially viable company, but also is affordable for the farmer. Then we looked at who supplies these cold storages. So we shortlisted about 20 suppliers and arrived at a supplier who we have a very strong partnership with, and they have provided all our cold storages for the last 2 years. And it's a really great partnership there. The cold storage itself. So what are the effects of portability on a cold storage? How many solar panels do we need, etc. And then what I mentioned earlier about as a service on its own does not serve our target market, but we needed to add a feature or a component to make it accessible and affordable to our customer group. And that took a few months to kind of bring those two together. We also looked at the business case for SocoFresh. So if we want to be a cold storage company, then how many cold storages does it take to break even? How can we scale this across sub-Saharan Africa? Because we are a sustainable model, we're an investable model. The validation of value chain. So what crops do we work with? We initially thought mangoes and bananas would be it, but we realized that to incorporate cold storage into your supply chain, you need to start with products that have that margin to accommodate the cost of cold storage. So we started with avocados because avocados are an export crop, and so the margins there are enough to cover the cost of incorporating cold chain. And so those were some of the learnings we had. And then, whether farmers want our services, so seeing them call us and say, oh, we want you to come. Why don't you come? You don't come fast enough. That was a sign that farmers really wanted what we were delivering, and they were engaging with us for this. And then, I talked about that. So I don't know where I'm at in time, but next slide. Okay, I think I'm on the last slide. So this is what I meant earlier. This is some pictures of our field. The value of combining market guarantee with cold storage solves our impact goal, which is to see all food saved, or a lot of food saved, and also ensuring that all produce goes through a cold chain. But for the farmer, it also works because a farmer doesn't have to invest any money to use our services. We take care of that. We get the market buyer to pay for the cold storage services. So we were able to build something really innovative that targets our client to really access some of our services. And I think that's maybe one thing I would leave everybody with is when you think about cold storages, think about the business model around it, think about your clients, think about scalability so that you can actually multiply the work that you're doing. That's my last slide. I'll end there.
Thank you. We'll hand over to Sonja now.
All right, thank you very much for that introduction and also flagging it out how important it is to have a business model in order to justify the implementation of a cold room. So now let's get a bit technical about what is this cold room and what do we have to keep in mind when we consider using one. Next slide, please. So here we see again that flow chart. It's a bit adapted from the one that Jakub had, but it has the same content. So the first question is a walk-in cold room the right solution, which Arpana gave some really good insights to make that decision. Now I'm going to talk about the point 2 to 5, so about what are cooling loads and what electrical power is needed, what size and type of cold room might be suitable for the use case, what about the location where it's going to be put, and what about the power supply. Then I think after that is when we are going to hear from Jakub about the business models and financing. Next slide, please. So let's look at the loads. On the picture on the right, we see a very full cold room, and that basically represents all the different loads that we have in our cold room. First, we have the transmissions through the walls, ceiling, and floor, as well as the solar gain. Solar gain is if our cold room is in the outside. It's obviously not if it's in another room, like a warehouse. Another one is the air infiltration at door openings, but also at the fresh air exchange. Fresh air exchange is necessary to filter out ethylene and CO2. That is something that is more happening in the high-end cold rooms. Many of the, let's call them rather more basic ones, don't have that, because for short-term storage, it's not that essential to have that feature. But of course, we have a fan, we have some motors and some lights inside that also produce heat. Then many cold rooms have a defrost system. Then there's also heat coming from pre-cooled produce, where the best practice for a cold room, a cold storage, would be to have a separate unit for the pre-cooling, and another one then for the final storage. Then, of course, if we don't have that separate pre-cooling facility, then we have the full field heat from the pure produce, but also if the produce already comes packed, or even just in crates or pallets, that also comes with a heat load. Then all organic items that we're putting there have respiration, that also creates heat. And then, of course, any equipment that we're putting into the cold rooms, like racks, or bringing in those little wagons to roll the products in, but also the people entering the cold room. And as well, if we have a thermal storage included, that is also a load. Next slide, please. Or next click. Yes, so some loads are constant and others are only operating at a short period. Like, for example, people going in. People are not 24/7 in the cold room. So that needs to be considered when we estimate the design day loading. So that includes, or the design day, basically, it's a compromise or a balance of the cooling demand and the cooling profile set somewhere above the average day and the typical demand, and the cooling capacity of the refrigeration system must then also match the heat load. Otherwise, you have spoilage of the produce. Next slide. So now how do we get from those heat loads to the actual electrical demand? So first, we need to list all those elements, which we did in the previous slides. Then we have to assess them in our design day. So we have to make a heat load and profile of that. if now the refrigeration system that we're using is a prefabricated one, it's easier because then you just look up the electrical input power of the condensing unit at your target temperature and for your use case. If not, then you have to estimate the coefficient of performance to calculate the power. Then you add up all the electrical loads. So your refrigeration unit, your lights, and all other electrical appliances that you have. Most times it's also some telemetrics included. So you list all of that, and that's how you calculate your power demand. And then from that, you specify your power system to meet that demand, and then you refine that design according to your load profiles, and also get back to doing an estimation or finding a balance between your loads and your costs. Next slide, please. Now we look at the type and size of the cold room. So there are various types of cold rooms. The first one that I've already mentioned is the pre-assembled cold room. There are some cold rooms that already come completely factory assembled as a unit. The advantage is that those ones can already be pre-tested, so it's very sure that there are no heat bridges, so that there's no little gaps where heat could come in. But of course, that can come very bulky and is sometimes not very practical. Next click. That's why one of the more common ones are the prefabricated or flat pack cold room kits. That comes as a kit with sandwich panels, and which are then assembled on site, on location. And that's done with, that comes as, it has a lock system where you can then interlock those panels and create an airtight room if it is well done. And that's also why, for the success for this type of cold rooms, it is essential that you have a local specialized personnel available. Next one, please. Then there are the reefer containers. That's a pretty standard container which is used in shipping. A lot those are very robust, prefabricated, most of the times 20-foot containers, and that have their power supply already inbuilt, and sometimes they can come with an auxiliary power supply through solar modules. The problem with that is that the doors are normally very heavy, because those reefer containers that are used for shipping, normally they are opened once to load it, then they are put on the ship, and then the next time that those doors are opened is to be unloaded, offloaded at the destination. And therefore it's also important to build in a safety mechanism that the door can be opened from the inside as well. Next one. Then we also have a range of self-built cold rooms. Those are small to medium-sized cold rooms that are built with local available materials and some traditional architectural methods. And there are several training institutions around Africa that have courses on how to do that and how to design and assemble this. And it's good because it enhances the local capacity building and works with what is available on the ground. So there's not much of imported stuff necessary. However, often the insulation properties of those rooms are not as good as those of either the pre-assembled, prefabricated, or those reefer containers. Next one, please. Then we have converted shipping containers. Those are standard shipping containers without insulation that are then retrofitted to become cold rooms. So that means that there has to be insulation added on the, most of the times on the inside of the containers. Then also that inside, or that insulated inside, at best needs to be covered with a food-proof painting. And also then, of course, the cooling unit needs to be added. And also here, for a shipping container is not made for many door openings, so retrofitting the door might also be essential. And also here, as a safety measurement, there needs to be a mechanism installed that doors can be opened from the inside too. Next slide. So now, what size of the cold room? How can we assess the right size of the cold room for our use case? So the size depends on, first of all, how much produce are you aiming to store in the cold room? And then what is the layout of the room? How much space is going to be taken up by racks and by aisles? Then also, which type of products are we storing? And are there different products in the room? What's their weight? Because sometimes that weight makes racks necessary. Sometimes those weights make racks very difficult to implement. Another point is, how accessible do those different products in the cold room need to be? So we have short-term storage versus long-term storage. If the use case is a cold room where various products are inside, and some have a quicker turnaround, so quicker in and out, and others are there to be stored for a longer period of time. So that needs to be considered. And then also, how uniform is the size of the basically of the crates or boxes or pallets in which the product comes in, and are they stackable? For example, in that picture on the right, we see that all those crates are quite uniform and can be easily stacked, and that the space is used in the best way possible. It is to say that larger cold rooms allow a closer control of the temperature and the relative humidity because of the higher thermal inertia. And they have better use of the storage space because the ratio between space taken up for aisles and racks versus space where actually product can be stored is better. But of course, they also mean much higher investment costs. Next slide, please. So let's look at the site and the site assessment that needs to be done before bringing a cold room. So first of all, it is important to review what infrastructure is there on the ground. Is there even staff available to operate and run the cold room? Are they properly trained as well? How is the logistical access? Number one, of course, for the delivery of the components, but then also for the delivery of the produce that needs to be stored. Because if the location is very difficult to access and might even not be accessible, for example, during rainy season, that site might not be the best to put your cold room, to make a viable business with that. And then I mentioned the rainy season. A site survey is very essential to establish the load-bearing capability of the subsoil. So can the subsoil support the cold room? And also, what are the risks of natural disasters? So we had the example of Kenya. Here in Kenya, we had really heavy rainfalls in the last month, and that led to some flooding. So that should be assessed before. How safe is that location against those climate risks, but also risks like earthquakes? Then another step that needs to be taken when we look at the site is the site preparation work. So is there any vegetation that needs to be cleared, and does there need to be a foundation work to put the cold room infrastructure on? Is there a shaded space available to store the produce on arrival? Is it also a kind of a clean pathway to get to the cold room? Also, together with the shaded space, is also how clean is the entrance of the cold room, so that we don't bring mud and germs and other cross contaminators into the cold room. Another important thing is those cold rooms, they need access to electricity, and how is the quality of that power. If solar is considered to be one of the power sources, then the incident angle of the sunshine needs to be assessed, and as well as a shading analysis must be done to maximize the power harvest from those from that solar energy array. Then, of course, seeking the approval from the planning authorities, and that is a point that sometimes, depending on the country and circumstances, is underestimated, because that can really take time, so that one should be planned well ahead. And also all those steps should be at best done or included in the planning process with enough time ahead. Otherwise, you might have the delivery of your cold room, it is already arriving, and you're not ready with, for example, your foundation work, or you have not cut down some branches that are going to be responsible to shade your solar array. So those are points which are often, some of them are forgotten, others are underestimated in the time that they take. So those are really things that need to be considered and planned well ahead when planning for a cold room. Next slide, please. Then the power supply. There are different ranges of power supply. So the one is the reliable grid, where a grid connection at the location is available, and it also is available with of a good quality, and is 24 hours at best, but at least 22 hours per day available. Then the limited supply, that means that the grid is available of good quality, and you have operating hours that are around 22 hours, but it is the power cuts are usually known before. So there comes in mind the case of South Africa. Then the other case is the unreliable grid, where there is grid available. However, it is not known for how many hours per day or it is available, and how often you're going to face power cuts. And it is also the quality of the power supply is not constant. So in this case, some form of electrical or thermal storage is essential in order to run a cold room. Then we have also the off-grid supply, where there is no grid electricity available at the location. And in this case, you will need a standalone power generation system. Next slide, please. So for those power supply types, there are different strategies. So when we have a reliable grid or a limited grid, then the primary power source can be the grid electricity, and with different options as a backup. So either a thermal energy storage as a backup, or an electrical storage in form of batteries, or an electricity generator, so a genset, for example, or a hybrid combination of 2 or more of those options. Now, when we look at strategies for unreliable and off-grid situation, then in those cases, we will need a standalone solar system that then can be backed by either thermal energy storage or by electricity storage in form of a battery or a combination of both. When designing for your backup strategy, things to consider are for how long is an operation without power necessary? Then also how temperature sensitive is my produce inside the cold room, and what's the economic value of that produce inside? So basically meaning if really the power goes off, how much am I losing with that? And can the produce inside the cold room bear a difference of or an increase in temperature of let's say 1 to 5 degrees, or is that already very critical to spoil my produce? And then of course also what are the costs of that backup option, and also not only the costs of buying that, but also we need to consider what's the lifespan of that backup, and also what are my maintenance and repair costs of those. So let's just take a battery, for example. An electrical battery, even if it's lithium in tropical environments, has a lifespan of around 5 years, and the cost of battery is quite expensive. So is that really the solution to go for, or is a thermal energy storage better? And then also we need to consider the environmental impacts of that. So is a diesel genset as a backup really the one solution to go for, or is it better to then opt for a thermal storage? And also how energy efficient are those solutions? So all of those are points to consider when making following that decision-making line on your way to designing your cold room and then getting your cold room. I think that's my last slide. Yes. Yes. So thanks very much for your attention. And I think the deeper dive into all of those technicalities will then happen in the next webinar in June. So if I tickle the nerve with those things, make sure you come by then. Thanks.
Excellent. Thank you, Sonja and Arpana. I saw there are already some questions in the chat, so let's quickly run through the business models and financing and then pick them up afterwards. Next slide. There are various guiding questions that can be used as prerequisites for sustainable business model when it comes to cold rooms. So these questions that are summarized here in a couple of bullet points can really help the project developer to identify value chains with the highest potential, ensure reliable market access to create good logistics and operations, and achieve high utilization rate of the cold room. So all these aspects were already touched on by Arpana with their SocoFresh model. So let's unpack the key considerations that are summarized on this slide. Starting with market linkage, that's extremely critical in determining the price that the farmers or market vendors can secure for their produce, or aggregators who actually buy the produce from smallholder farmers. Now, the type of market is, of course, very important. It can include local village markets or larger markets in towns, as well as export hubs like shipping ports, airports, or large cities. And all these have very different dynamics. From a physical infrastructure point of view, the distance to the market, the quality of road infrastructure, and the existing means of transport are all very important when designing the full cold chain and creating market linkages. And all these elements really influence the decision-making process for farmers and market vendors. And then they decide whether they will sell their produce to the cold room operator or find value in potentially using the cold room themselves. The next is the characteristics of the actual value chain, and that can include the type of produce, seasonality, how much volume is produced on kind of annual or monthly basis, and also the specific needs for pre-cooling and cooling, which again is related to temperature and relative humidity that Sonja already touched on. Then we also need to consider storage duration and farming practices, which all come into play. Now, cold rooms usually serve various types of users, so they can include individual farmers, farmer groups, producer organizations, and cooperatives, as well as marketplace vendors. And we'll look at some of the case studies later where market vendors are using cold rooms on a daily basis. And it's really important for the cold room operator to understand the diverse user base for them to tailor the business model and the pre-cooling and cooling services to their respective customers. Now they need to understand user profile in detail for effective planning and implementation. And again, this can include the number of users that actually use the cold room, the diversity of their income streams, and their actual income from farming or trading activities. And this should be ideally broken down per month or season, especially if it is used as a service for the operator to understand how much the income they might receive from the customers using the cold room. And this information should ideally be cross-referenced with the volume and type of value chains and taking into account any price fluctuations that actually happen on the market. Now, when considering cold storage specifics, it is important to assess users' current or previous experience with cold rooms, and this is very important for capacity building planning. So some communities may have already been exposed to cold rooms before, so they know very well how to operate them, but in most cases, cold rooms are brand new infrastructure in their communities, and therefore, if they are the ones using it, then they need to receive appropriate training to do it effectively. Now, also, it is important to understand the customer's interest in either using the cold rooms, whether they have preference for lease to own versus service-based contracts, or whether they actually have no interest in being directly engaged in the cooling itself, and it makes more sense to buy the produce from the farmers and having this specialized entity actually doing the cooling and the subsequent market linkage themselves directly. And finally, it is important to recognize that cold rooms are part of a much broader food system, and sometimes it can be more economical to store products in ambient conditions rather than cooling them, or sometimes there might be other technologies that may be actually more suitable, again, as we discussed with the example of extending the harvest season by using irrigation and building greenhouses rather than cooling themselves. So all these competing forces must be considered when validating the cold room business model. Next slide. In this guide, we identify kind of 6 main business models that can be pursued. That's definitely not an exhaustive list. There are many different innovative ways how the business models can be structured, but these are kind of the main ones that we focused on in the guide to start with. And there is a detailed description and comparison of the advantages and disadvantages in the guide. So I will only touch on the main aspects and just reference some of the case studies, but you will need to read the guide to get a full picture of that. Now, starting with the first rental model, in this case, the company who owns the cold room rents the space to customers. And then the customers in turn pay a monthly or seasonal fee to use the cold room. And it is really up to them how much they actually use it. So this means that the utilization rate risk sits with the customers who pay for the space on monthly or seasonal basis. Of course, the rental model provides more certainty for the cold room owner since they get paid on a regular basis. But unless the customer produces enough produce on a consistent basis, it can also mean that they might not utilize the full space and therefore not use the cold room as effectively as it could be. And we have got a case study from Freshbox discussing the key advantages and disadvantages of this model in the guide. Next model, very promising with relatively limited case studies to date, is the pay-as-you-store model, which again is a service-based model where customers don't need to own the cold room itself. So in this model, customers pay for the actual use usually on a daily basis, whether it's per crate stored or kilogram or liter of produce stored or similar unit. This model incentivizes the users to use the cold room space effectively, and then of course sell the produce as soon as they find a buyer, because the sooner they sell it, the sooner they get paid, and they don't have to pay for the cold room space on a daily basis. And equally, the operator is incentivized to operate the cold room effectively and maintain it regularly, since they rely on high customer satisfaction. Because simply if the cold room stops working, then the customers stop paying them, because they pay for it as a service. Now that all sounds fantastic, but there are some challenges associated with this model. So one is income unpredictability for the owner of the cold room, and there are also relatively long repayment periods associated with this. So there might also be some issues with mixing different produce in the same cold room, and we can unpack it in the Q&A later, or it will also be a main topic for the next webinar to discuss kind of what type of value chains can actually be stored together in the same cold room. But in this pay-as-you-store model, since the owner is incentivized to use up the space as much as possible, there is the risk that they would kind of accept produce that actually shouldn't be stored together. So this needs to be avoided. And we have got a really good case study from Cold Hubs, how they have overcome these challenges and use pay-as-you-store model in Nigeria in marketplaces. Next one, we have got the aggregate model. So in this case, the cold room operator buys produce from smallholder farmers and sells it in bulk. Now, the advantage is that it can attract higher prices because this entity has much stronger negotiating position, and they have aggregated the produce, and then they can sell to larger off-takers, for example, supermarkets or potential exporters for export markets. Now, the advantage of the aggregators is they can also offer some other services to the farmers or farming cooperatives. So it can include sorting, grading, packaging, or also kind of drying and processing produce for other purposes, like Arpana mentioned, that they are doing with Soko Fresh and Champagne Pro in parallel. And again, the advantage is that the farmers can actually focus on what they know the best, and that's growing and harvesting food, and they don't have to deal with the complex technology of using the cold room, but also of securing and monitoring market prices and making sure they always get the best value for money. There are, of course, some risks associated with the aggregator model. One is that the aggregators take the risk. So, for example, if they're focusing on single crops, they can be highly dependent on seasonal market prices. And they need to be usually a very specialized firm who understand the complex markets, especially when it comes to value chains that are exposed to the global market price fluctuations. And we have got a really good case study from Soko Fresh in the guide that you can dive deeper into it. Next up, lease to own model. It's essentially purchasing the cold room over time. So if you're familiar with the Solar Energy Kits market or Solar Home Systems, then that's kind of your pay-as-you-go model, where generally the product is repaid over time, and then after a number of years that's set in the contract, you own the system. This model is generally suitable for wealthier or larger farmers, or kind of agriculture enterprises or cooperatives that have sufficient resources and knowledge to operate the cold room, and also for them to grow enough produce to actually fill up the cold room on their own. And usually companies require a deposit, which, if we say roughly 15-20% of upfront cost to sign a contract, that can be quite substantial for a cold room that costs $20,000 plus. So that's why the market is maybe more limited, especially when it comes to smaller farmers and marketplace vendors. The payment default risk is the main challenge for the cold room suppliers, as with any other financing scheme out there. And we have got a case study from Jungle Harvest in Kenya in the guide. Next one is perhaps the most straightforward. That's the upfront payment model. That's a very conventional business model. There are short working capital cycles for cold room suppliers, so of course they like it, but the market for this is relatively limited when it comes to the actual addressable market, because only large agricultural companies or perhaps projects that have already secured grant funding can afford to pay for the whole cold room upfront. Otherwise, most customers that we are talking about here in off-grid areas in the global south won't have the capital to pay for the whole cold room upfront. And then last but not least, we've got mobile services. That's a relatively emerging model. Here we are talking about kind of small cold rooms that would be mounted on trucks or trailers, and it could serve kind of remote communities or seasonal farming areas, or provide temporary food storage needs for different events, for example. For this, we would require decent road infrastructure, and also there is a limitation how much can be actually solar powered when it comes to this solution. It's so far not been too common in rural areas, but we have got a case study from Cool Fresh in India who are trialing this specific business model. And maybe I should also say that these are not kind of mutually exclusive. We have heard from Arpana that they are kind of pursuing the aggregator model, but their cold rooms can also be moved around. So there are kind of some links between these different models. Next one. Now, this is kind of the final slide for the content itself, and that's looking at different financing options for cold room developers and operators. Many developers have been able to secure grant funding for pilot cold rooms, but there is only a small number of cold room companies who have been able to secure kind of larger commercial investments to scale up. Usual financing challenges for developers who would not sell their cold rooms upfront would include kind of the usual challenges that any asset financing provider would face. So that's the cost of working capital, foreign exchange risks, default and late payment risks, and then costs associated with payment collections and transaction costs. So again, there's nothing unique really about the cold rooms themselves. The uniqueness of cold rooms is they are usually substantially more expensive than other off-grid solar products, and usually the repayments are longer, or they need to be longer, especially for service-based models like rental or pay-as-you store. So that's kind of the main uniqueness of the financing aspect. Again, it is still quite a nascent sector, so the vast majority of cold rooms deployed to date have been supported either through grants or leverage some sort of blended finance instruments to de-risk investment for the private sector. So in the guide, we actually dive into every one of these individually, but I can give you a very quick overview of some of these financing types, starting with grants and other subsidies, perhaps the most common to date when it comes to cold rooms. We have got various grant providers that have supported cold room developers, including the Efficiency for Access R&D Fund, Powering Renewable Energy Opportunities, and EEP Africa. And there are also some RBFs, like the Productive Use Financing Facility, that includes cold rooms as well. Next, blended finance instruments. That's typically a combination of grants and then equity or debt. We have got some examples of combining this concessional financing from perhaps development institutions or philanthropies with commercial funding from the private sector. So to give you a couple of examples, for example, the investment from Acumen into Sokofresh, or Kavisafe investing in Inspira Farms. It's kind of this example of blended finance. Now, pure commercial equity is usually quite rare in the solar-powered cold room space so far. There's pretty much the only example of Series C that Ecozen managed to secure last year. So they secured 25 million US dollars, and that's been the biggest commercial investment in the solar powered cold room space so far. Debts, we define it as loan to be repaid to the lender with interest. Again, since this is quite an emerging technology, commercial banks have been quite reluctant to lend to companies to operate cold rooms. So there are some alternatives that could be potentially explored before the commercial banks are interested in the sector. So it could be off balance sheet financing or asset backed financing, which we explored more in the guide. PPP or public-private partnership that typically involves longer-term contracts between the government and a private company that wins the tender to provide public goods and services. And it is very common when it comes to kind of wider services provided by governments. But it's the experience with cold rooms is quite limited so far. There is a good example from the smallholder dairy sector in India, where the government of India really rolled out milk chilling at scale, but specifically to cold rooms, there hasn't been too many large-scale examples so far. And then finally, we've got carbon credits, which of course is a buzzword nowadays. Many people are interested in it and talk about it, but at the moment, there are no carbon credits available specifically for cold rooms, although they might be able to tap to some existing methodologies. Most carbon credits so far in our off-grid solar sector have focused on cooking, lighting, and there are some pilots on irrigation and refrigerators. And there is a potential that we could expand it into cold rooms, especially if avoided food waste could be monetized. There's actually quite a lot of initiatives in this space ongoing. We have got the Global Off-Grid Solar Association, GOGLA, who have got a new working group focused on this topic. And we at Efficiency for Access are planning to do research in the productive use and carbon credit space. So please do reach out if you would like to find out more about these new initiatives, and I can connect you with the right people. So that's everything we have got in terms of content. I think we are still good with time. So let me turn into the Q&A. Thank you so much for asking questions already. I see that some of them have already been answered. I might actually follow up with you, Arpana, to start with, if that's okay. There was a question from Amit about the nature of the problem being solved for smallholder farmers, and I saw that you already answered his question, but just to follow up on that, how do farmers actually benefit from your solution? And maybe like if you could talk a little bit about how Sokofresh and your other ventures are benefiting the smallholder farmers themselves. Can you hear us okay? I think Arpana might be having some sound issues, so I'll drop her a note separately and maybe turn to you, Sonja. So we have, unless you have already answered some of the questions with ethylene gas buildup in different producers, it's quite a specific one. Is there anything you would like to build up on?
Well, ethylene gas in short-term storage, depending on the mix of produce, can not be such an issue. So especially if you have a commodity which is low in production of ethylene and is also not very sensitive to ethylene, and you just store that commodity, then it's not so much of an issue. But especially in long term storage, so when you want to store a commodity over a longer time, then you at least want to measure your ethylene, and at best also have something in place to control your ethylene. So there are either you have separate sub sections in your cold room for the different products, or you actually have filters built in and you have a high air exchange rate where really the air in the cold room is exchanged with air from outside. Because that's then how you control. And if we now take the industry as a reference point, in the industry, cold rooms are also referred to as controlled atmosphere chambers, so that in the industrial standard ones, especially for the long-term storage, that's where really all the air is completely controlled. So they know how much ethylene is in there, how much CO2. So there, what is done there is increasing the CO2 volume of the air to reduce the ethylene production. But also, just storing the product at the optimum storage temperature can help inhibiting or slowing down the ethylene production, because ethylene is a product of respiration, and storing the commodity at the perfect storage temperature slows down the respiration, and therefore also slows down the ethylene production. So the most important thing is, in my opinion, to store your commodities at as perfect storage conditions as possible. But if you have a mixed storage, then you must know what are your products. Are they sensitive to ethylene? Are they high ethylene emitters? And then take measurements accordingly. So if it's, let's take, for example, a cold room which is installed at a marketplace, well, then maybe because you cannot allow to have leafy greens in your cold room when you have a lot of tomatoes in there, or you require them to be packed. There are those modified atmosphere packagings, so that you only that's now for not for the very informal domestic market, that's then more for the higher end market or export, to have your commodities packed in modified atmosphere packaging, so that you kind of have their own controlled atmosphere inside. So those are some advices to give, but most importantly, you need to know your products. Thanks.
Excellent. Thank you so much, Sonja. And again, if you would like to find out more about these specifics, please do join our next webinar, which will dive into some of these aspects in a bit more detail. Great. Arpana, can you hear us okay?
Yes, I think I can. Can you hear me?
Yeah, perfect.
Okay.
Very good. So the question is, how do smallholder farmers benefit from your specific solution when it comes to Sokofresh and other ventures that you have co-founded under Enviu?
Yeah, sure. So with Sokofresh, farmers have a hassle-free route to market for their produce. They know that they don't have to, it really is a low effort kind of engagement. And they also know that we will offtake nearly all produce from their farm through our mix of solutions. So when a smallholder farmer sees a post-harvest loss of 50%, which shaves their income to that extent, by being able to sell all their produce, you're naturally increasing the money in their pocket. So it improves their livelihood, it improves their ability to really invest in farming and in technologies and innovations. And the other is, and that is really the effect of providing cold storage and market linkage together at farm gate. The other is, as a lot of our businesses are based in rural Kenya, we create a lot of jobs, we create growth. And because of a lot of our activities, really create opportunity for groups of people who haven't had access to jobs unless they went to urban areas. We also see that kind of impact happen there. And then there is the environmental benefits of using circular technology that is accessible to off-grid regions or low-grid regions. And by off-taking what produce that could be thrown away, you're also reducing the emissions. So that's the environmental benefit that we see.
Amazing, thank you. Now there are two questions that I can potentially bundled together related to the role of quality standards and benchmarks. So maybe I'll get us started and then hand over to Sonja to tell us a little bit more about this. So there is actually a new quality assurance framework that is being developed under Verasol with funding from the World Bank that is literally just kicking off. There was the first meeting, I believe, last week, and there will be now ongoing meetings with interested stakeholders to shape the framework, because it's still, cold rooms are still relatively emerging technologies. So now is the right time to shape these quality frameworks to inform the sector and integrate it as part of Verasol. And Sonja, I believe you're part of that working group, right? So maybe you could tell us a little bit more for people who might be interested in this space and how they can get involved as well.
Yeah, so there is now the quality assurance framework for walk-in cold rooms being developed. So that means to have a minimum standard for quality of a walk-in cold room. What is a must that has to be in there? What is a must that must be provided by the manufacturers and suppliers of walk-in cold rooms? So that is being developed at the moment, and there are also stakeholder engagement workshops. The next one is going to take place, I think, in July. We are having a mailing list on that. So in case you would like to be part of that, drop me an email and I can include you in that list, and then you will be informed about the next stakeholder engagement webinar that is taking place, where you can then also give feedback on the development and what you as a user of cold rooms, or as a provider of cold rooms, or as a project developer think should be in that quality assurance framework. However, I'm not sure if now that question is entirely about the technology or also about operation practices, because that's what the Jan was referring to. I think it's standard operational procedures. I think that also involves the general post-harvest management, which in my opinion already starts before harvesting. So point of harvest are, for example, one of those best practices. To not harvest in the middle of the midday sun when the produce is the hottest and then bring it to the cold room, but to harvest in the early mornings when the temperature is generally the lowest. And then a cold room is not a magic machine. Quality that has been destroyed cannot be restored. So the maximum a cold room can do is preserve the quality that is put into it. So it's super important that no spoiled, rotten, or damaged, contaminated produce is getting into the cold room. So I think those are also some of those standard operational procedures that in the local context, that on the ground, need to be established in order to have a successful working cold room. Because often it's not the technology that fails, often it's the operation that fails, and that starts already with the original quality of the produce and time, and also practice of harvesting, practice of handling, to store the tomatoes carefully in crates and not throw them around in plastic sacks and then bring them in a very densely packed sack into the cold room. That has an effect on the quality so often, and that also comes back to that first question that you raised, Jakub. Is a cold room always the solution? Sometimes it's also the change in post-harvest handling and those practices, because that also has a big impact on the quality of the produce. So I hope that covers those two questions in a more holistic way, also shining a light on the actual agricultural and commodity handling of the products that might end up in a cold room.
Absolutely. Thank you, Sonja. And again, in the guide, we dive a bit deeper into these different value chains and how they should be handled, but there is much more detailed assessment and guidance on, for example, the Wageningen website, where they really focus holistically on post-harvest management. So there are definitely lots of resources. And I believe that many people are already sharing resources in the Q&A, which is excellent. So everyone can have access to them. There was also a question about different slide decks. So we will be sharing the recording and the full slide deck with everyone who registered for the webinar. And we'll also include more information how to join the working group with the quality assurance framework for walking cold rooms that Sonja referred to. So all these resources will be shared with you in due course. Now we will have time for maybe 1 or 2 questions. There was one related to carbon credits from Ecos and Solutions. So maybe I can get us started on that one. As I said, carbon credits can potentially be a viable financial stream into the operations of cold rooms, but as far as I'm aware, there haven't been any pilots specific to cold rooms. We have got some pilots on refrigerators that are kind of much smaller scale than cold room, and Coolbox are trialing that in Nigeria and potentially a couple of other companies as well. But in terms of cold rooms, that's something that we want to include in our upcoming research to look at how this could be potentially viable, but I'm not familiar with any existing pilots or projects. I wonder, Arpana, if you have come across any carbon credits used for cold rooms, or if this is something you have come across.
No, nothing yet. But curious also to see that development.
Great, thank you very much. Right, there is one more question on smallholder applications in terms of lower yields and initial quality. Is that something that Sonja or Arpana you would like to pick up? It's the last question from Jan in the Q&A.
Oh yeah, that concern is absolutely right. So that's also coming back to what I said. A cold room cannot improve the initial quality. So actually teaching and informing on best practices in agricultural best practices is absolute key. And that also is one of the things where smallholders need more information and more training on to really have those that I said, like the just how you harvest and when you harvest, that does not require a lot of monetary inputs. It's a matter of training. That's really, and also lower yield levels. That's another issue where I would say cooperatives or farmer associations are the one where when multiple farmers come together, then that makes sense or can make a use case for a cold room. Of course, there is no use case for one smallholder farmer who, let's say, produces cabbage to have a 2 metric ton cold room on his farm. That is absolutely not the use case, and there are other low-tech or no-tech solutions that will help him with that field heat removal more efficient and more in a cost-effective way than deploying a cold room. And that comes back to, Jakub, what you mentioned before, those white elephants. You really need to know your ground. You really have to do a thorough baseline study in order to find out if a cold room at that location and in that use case is the solution or not. And so this guide also is trying to help to make that solution. And the concern about the smallholder application with a cold room is definitely a question that needs to be asked. And at a single smallholder farmer that does not produce a high value crop, my opinion is a cold room does not make sense.
Thank you, Sonja. And on that note, I think we will have to wrap up this session. Sorry.
We have one question, Jakub, from Leo Blythe. Would you be happy to take a question from Leo?
Yeah, we can do that. Maybe if you can unmute Leo and he can speak about the carbon credits for 2 minutes, and then we'll wrap up the session.
Thanks. Hi, everyone. Yeah, just a quick one. So I think Eco said you'd probably know more about this than most people, the issue was involved in carbon credits. So I'll use your question just to give a quick status overview. So what the current situation is that the as Jakub said, there is no methodology for carbon credit accounting for walk-in cold rooms. Methodologies need to be developed. It's a long, onerous process needing hundreds of thousands of dollars and multiple years, and it has to be approved by the UNFCCC. In order to get there, one first needs to note what are the emissions you would be reducing. And that therein lies the problem, if you like, and the progress is being made. So the first step are monitoring the food loss and waste. And again, emissions are different from different types of food, how much food and what. So it's very complicated is the long and short of it. I'm personally aware of several different initiatives that are working on part of this problem. And maybe as a follow-up, what we could do is the most comprehensive and publicly available information has just been released last week by the IFC, private sector wing of the World Bank Group, on food loss accounting. So if you like, that's the basic tool that any company such as yours could be using to determine the carbon impacts of rotten food. And that is the starting point. You know, it's very complicated because then you would need to determine what then happens afterwards, etc., in terms of food loss and waste, you know, and is the food actually rotten? Is it used for another purpose? And then all manner of other very complicated calculations. So that's why there's a concerted effort needed. And we haven't seen one to date, although individual companies have done a lot of work. Hope that was helpful. It was a quick overview. Thanks.
Thank you so much, Leo. It was a really good overview about carbon credits and the next steps that we need to do as a sector together. So yeah, now unfortunately, we will have to wrap up this webinar, but thank you so much everyone for joining. You can access the guide and the overview document on our website through the QR code that you can scan here, or just simply visit our website. The next webinar will be hosted in June by our colleagues in the International Institute of Refrigeration. So please watch the space for that one. And then there will be one more webinar by Wageningen University and Research to provide insights on operations and lessons learned from the field. Now, you can always reach out to us with any questions you may have. As I said, we'll follow up after this webinar with the recording, the slides, and all the information that was requested throughout the session today. And yeah, thank you again to our speakers, to Arpana and Sonja, and I wish you a very nice rest of your day. Thank you.